So next up, we are going to have a live presentation from Jordan Rash. He is going to be presenting on a new Synadia product called Workloads. And this is particularly exciting as this enables a lot of use cases and doing processing at the edge. I think there's some really exciting stuff that can be done with distributed inference too, speaking to that AI topic. We heard earlier I think it was PowerFlex or no, Machine Metrics had talked a little bit about being able to distribute some of the processing and being able to take advantage of edge devices to do little bits and pieces of processing that would otherwise need to happen on cloud servers somewhere. And I think that this product is going to lead to a lot more capabilities of doing that and really empowering this kind of nothing but NATS stack. And I won't speak too much more to it, but I believe Jordan should be joining us momentarily here. There we go.
Awesome. Am I here?
You're
Thanks
here.
so much, Nate. I'm excited to be able to talk about this today. Let me see if I can share some stuff. Cool. Well, thanks everyone. This has been a great Rethink Con. I hope I can keep the vibes going. My name's Jordan. I am one of the members at Synadia trying to bring the NATS execution engine and workloads to the community. Today, I'm hoping to talk a little bit about the state of the NATS execution engine. We've been working on it about a year. We've gotten amazing community feedback, and I kind of hope it shows when I bring up the demos here in a little bit. We're going to discuss some motivations on why the changes we made, and then hopefully I have some exciting announcements. So first off, we can't talk about workloads without talking about Next, so the Next execution engine. So for those of you that aren't aware, uh, the Next was built to try and bring your business logic to the NATS ecosystem. We do that by trying to unify various runtimes and at the same time utilizing all the NATS primitives that's made it such a powerful platform. KV, object store, streams. We give you all that for free, bundled when you run your workloads. One of the things I want to point out, and Derek talked about it early on, was the order things were built. When I started working on Nex, I was like, we've made these engines before. We know all the things we have to hit. Networking, we got to get firewalls, we get security, we got to get all these things. Well, turns out since we built our connectivity layer first, and then our data layer on top of that, Next inherited security. Next inherited replication of data. It inherited KV. It inherited object store. So we got to use all that for free, and by starting workloads and aligning, trying to like associate them with things like scope credentials, like we can make the connection between the two pretty seamless. All right. So reintroducing Next. It's been an exciting year. We early on we built the platform. We were really happy with it, and then we're like, let's take it somewhere other than the cloud. Let's take it somewhere other than the server. And we realized that we had packed everything into a single binary, and it was starting to get really bloated. So we're like, let's take a step back. Let's consider the architecture. Let's consider, do we need all the dependencies we've brought in? And can we build this completely on NATS primitives? Spoiler alert, we could. And that's what I'll share with you next. One of the biggest ways we did this is we decoupled the core, so essentially the control plane layer, from the agent layer. So you see on your screen this word called Nexlets. Well, Nexlets is the term we coined for essentially what is going to be agents in Nextland. So they've been built completely on top of the NATS micro construct. So that means at this point we can build Nexlets to extend Nex on any NATS client that supports micro, which is pretty much all of them. So I kind of went over this, but building ballooned, build tags were getting kind of hard and confusing, and debugging was taking a very long time. Those were a lot of the motivators that kind of had brought us to the re-architecture. And then we looked, let's embrace nothing but NATS. We have Orbit, which we're using, and it took out a lot of the custom logic on how we like parsed messages over NATS. We have Micro, which brought us pretty much everything we needed from a lightweight agent framework. And we're really happy to say, as of today, Nex is a nothing but NATS application. The only external export it's bringing in is something we use to validate JSON schema. But we're hoping now that we have Orbit looking at schema validation, we can pull that in, and then our dependency list will be completely Synadia and NATS based. The other big thing was the edge. We kept talking about the edge. Next wanted to bring workloads from the edge. And then when we sat down to define the edge, like, what does that mean? Turns out it means something different to everyone. My edge could be a name frame. Someone else's could be the cloud, and someone else's could be an ESP32 doing soil samples on a farm. The edge is not concrete. But one of the key values of Nex was these workloads need to be able to move to whatever edge, and we need to be able to meet people where they're at. So that was another big motivator. And lastly, the community. We had so much positive engagement with Nex after a Rethink Con last year, people sending in like what they wanted to see, where the limitations were. We're like, okay, we're not going to be able to fill all these things, but what we can do is make Nex pluggable and flexible so that the community can build, and then we can create kind of an ecosystem around Nex as well. So that's essentially what we did. Nex Core is very lightweight, and it's essentially what used to be Nex. You can start it. It doesn't have agent or Nexlet dependencies. But something that's very exciting, and we'll talk about here in a minute, is the type of agencies we can, Nexlets we can plug in. We've built some pluggable pieces such as credentialing and state. So when you start agents and you start workloads, the nodes are actually minting credentials real time that are scoped to the subjects that those things need to talk to. So if you start a workload in account A, it's not going to be able just to listen to and talk in the account B unless you intend to do that, which is another flexibility thing that I think is going to be really valuable. And then we come to the type of Nexlet. So Nexlets is one of the things I'm most excited about because it does let us extend to wherever we want. The node itself has the ability to run 3 types of Nexlets. They are all built on the same SDKs, but they're just started differently. An embedded Nexlet is essentially something that uses the Go SDK because Nex is Go. You can compile it in, it makes a single deployable unit. So that means you can take that node with that Nexlet, single binary, put it wherever you want. That really helps with ease, and that's how I deploy it in my home lab just to make my life easier. However, that limits you to Go, and that does not embrace flexibility. So local-based Nexlets are something that are something Nex will run as a child process. These can be written in any language you want. Rust, anything that NATS client micro supports. Which then when you look at things like Firecracker and all the other micro VMs, they're all typically written in Rust. So instead of doing like the Go SDK wrappers to interact with Firecracker, we'll be able to talk to them directly. And then the last one's the most exciting, remote. So we thought, how do we get Nex as far out to the edge as we can when it doesn't make sense that the control client is all, or the control layer is running out there as well. So we made it. So we created a way that you can compile a Nexlet, make it aware that it will be connecting remotely. You ship it to wherever you want, and then you maintain like state process of it. So you put it in system D, you keep it running, and then from there, it extends Nex all the way out to wherever you put it. When I have I think, fun demonstration here in a second to show just that. Just a few more things about Nexlets. Life cycles. So the types of workloads that we decided that we should be able to support. Services, job, and functions. They're all kind of self-explanatory, and they just kind of mean different things to how we monitor. So if someone were to submit a service, that's them telling you like, hey, if this dies, please restart it. Please try and keep it up. Functions are something a little different. They're kind of like a service in which we keep them warm. However, they're not. They get put on the node, and the code is invoked via a trigger. So you would send a message over a NATS topic subject, and the next node would be kept warm. It's listening on that subject, and as soon as it gets a valid request, it spins up your workload, runs it, and shuts it down. This is a way just to like minimize the amount of downtime, kind of like functions as a service. The other big flexibility thing is Next doesn't define what your start workload request has to look like. When you're building your Nexlet, you get to tell us that, and upon registering with the node upstream, you say, this is what my start workload request looks like. The node's like, got it. And anytime a workload request comes in, we actually validate it so that it doesn't get sent all the way back to you if it's bad. And then if it's good, send it back. And then from there, the Nexlet takes it on. And then we kind of make things, DevX things like the Next file. It's essentially a more succinct way to start a workload without having to type out a bunch of commands. So I'm going to try a demo. I will explain it first. So locally on my computer, I'm going to start Next. I'm going to start it with no agents. Then I have a Raspberry Pi in the other room that I've SSH'd into. I'm going to start the agent or the Nexlet. You're going to see the registration, and then we're going to start a workload on that Nexlet. Now, this is real fun because what I've tried to do, even though it's a little silly, but it's fun. We will send a message to the workload. The workload is aware of GPIO on the Raspberry Pi. It will then send the message over 915 megahertz to this Raspberry Pi that I have sitting behind me that is air-gapped, not on the internet, nothing. It's just listening on 915 megahertz. That Raspberry Pi will then do sentiment inferencing. It'll look at the message, decide if it's neutral, negative, or positive, and then it'll send it back. Then the agent will send it back to our node. So if it all goes well, we should be able to see sentiment analysis over the air. All right, now let me change some screens around. A quick download of the screen. So over here, what we're going to do is we're going to start Next. And we're going to look at the node, and we're going to see that we have no agents running. So there's really nothing that this node could do at the moment. So if we start the external agent over here on the Pi, you'll see all of a sudden an agent's registered. We'll relook. We'll say we now have this remote agent running with no workloads. Now I'm going to show you what that agent's unique start workload request looks like real quick. So the only thing that that agent's expecting is a NATS object store reference. And so what that means is we're going to send it with a reference to, sorry, find it. There we go. We're going to send it with a reference to this binary right here that's sitting in the object store on the NAT server on my computer. The agent's then going to go pull the binary, save it locally, and then start it. So, all right. So now we have one workload running on this agent over here. And you see that it saved the binary from the object store to its local disk. Now, if everything works, we're going to send it. Rethink con is great. You'll kind of see, you can see the messages coming in over the air. They come in chunks. So the agent puts them back together and then submits them. And then what we see black and under a second is that Rethink con is great. That is a positive comment, and it was done via air gap sentiment analysis. Fun example, kind of shows you inference on the edge and kind of how flexible that we can get and how far we can push workloads. So this brings me to a really fun announcement. Synadia managed workloads. So much like we have the NATS global supercluster, we have deployed a Nex cluster, which we call a Nexus, in all the same regions as NGS. So a multi-node, multi-geo, high availability Nexlets that you will be able to run your workloads on in any cloud, in any region that we support. It's fully integrated into the UI of Synadia Cloud, which I'll show you in a second. Placement feels the same as Jetstream. When you want to go move your Jetstream resources from Geo US to Geo Asia, you just retag them. Same with the workload. If you want a workload from AWS to Azure, you just tag it and it moves it for you. And then we're going to try and demonstrate that now. All right. So now we're looking in Synadia Cloud. Looks very familiar to everything Seth showed earlier, except we have this Workloads tab. And if you look at kind of what I've got deployed here, you'll see that it kind of mirrors Scott's demo he just did for us. And in fact, it is Scott's demo. The only difference is I don't have a camera, so I have a load generator. And if we look here, I think someone will drop a link in the chat. We're actually running Scott's demo across 3 clouds running on top of Nex in Synadia Cloud. The bummer is there's no data, but that's because I haven't turned it on, and we're going to do that together. So let's share both. All right. Let me get these screens situated. All right. So I'm going to go to this tab first. What we're going to do is we're going to start. And since Synadia Cloud is multi-tenant, it is namespace to only my account. So you'll see now I am using normal a namespace reference to my account and user credentials that are essentially the exact same credentials a user of control plane would use. So we'll send it, and you'll see. I'm not sharing my screen there, am I? Sorry. All right, there we go. So you saw we sent the workload, and almost immediately we should start to see data get generated. There we are. And obviously a lot of you have found the button and you're clicking it. So what the button's doing is kind of where Scott put his hand in front to create the anomalies. you're all doing it with fake data. So that's a lot. I'm glad you all found it. Now, what's fun is if I go over here, I find my. Nope. Come on. I get logged out. Hmm. Oh, you know what that is? There's so many of y'all on this. You took up all my connections. Connections. Hold on. I can't even log into my own thing. Connections. Nope. I need like 500. Sorry. Save. All right. Workloads. All right. So now we've seen that our data source is living in GCP. And I don't like that. I wish I would have deployed it in AWS. So what we're going to do is while you're all playing with that, I'm going to take that workload. We're going to move it real time from GCP to AWS. And you should see almost no downtime. So there you go. If we go back to our hotbars, you can see it's speeding up a little bit. That's because for a brief second, both load generators are running. And as we turn it back down, you'll see it mellow back out. So essentially, what we've just done, and I kind of want to show, we now have our data source generator running in AWS. We have our inference engine, I believe, running in Azure. And I believe the other three, the HTTP website y'all are all interfacing with, is running in AWS. So multi-cloud, multi-geo application, all this is running over NATS, using NATS primitives. The state of this app pulls from a KV store. I believe that is, yeah, right there. So it's all sharing state centralized. So that's how we can start and stop things without missing a beat. So I believe, yeah, my only other slide said thank you. Really, thank you. The community's been great around the NATS execution engine. I hope we can continue to bring y'all great stuff. And yeah, any feedback is really welcome. Thanks all.
That is one of the coolest demos, I think, and seeing the workload move across. It's just awesome way to put that together, and also, live debugging as well, getting those connections
All right.
numbers sorted out real quick. That was perfect.
I knew as soon as I saw those purple markers, I'm like, oh, I wasn't expecting that many.
We got one asking, does it use Jetstream under the hood or only core NATS? I assume this is
So,
for Nex.
yeah, so Nex is pretty much core NATS under the hood. It's all published, request reply. Nex does go one step further. It is emitting events that we are saving to a stream so that we can do out of bound event sourcing eventually. I do know that the only other piece is by default Nex is stateless. So if you were to kill a node and turn it back on, you would have lost your workloads. However, in order to remedy that, there's an interface there that lets you implement state in different ways, and the official binaries will come with a KV backed state. So every time you start a workload, it'll store it, you stop it, it'll take it out. If you kill the node and turn it back on, and this is how the cloud nodes work, it'll read all the workloads that pertains to it, and it'll auto start them all. So that's kind of a disaster recovery mechanism.
Very cool. We got another. Oh, it just went away. I think Don was typing an answer. um, there was talk of being able to deploy based on type, so the agent pulls the appropriate binary type for the operating system or architecture. And is this still on the roadmap for Nex?
Yeah. So a lot of the responsibility we took from CoreNex and moved it to the agent. So things like if you have a Nexlet that is sensitive to OS and ARC, one of the ways you do it is you'd either detect that once you got the binary, or you'd stick it in your start workload request. Right now, we bundle just like we have since the beginning a native Nexlet, which is essentially takes a binary and runs it as a child process. We do bundle that with the actual node by default. You can turn it off. It will do a little bit of validating to make sure if you send it an AMD binary on an ARM system, it doesn't run it. But the good thing about it is we have pushed it down to where the author of the Nexlet can do what they please with that.
Right. And then we had Howard in chat just asking, where does Firecracker fit into Next
Yeah,
now?
yeah, that's a great question. So as it sits now, the biggest problem with Firecracker was we went. It was our main way of jailhousing all the our workloads, but it didn't run on Windows. It was hard to run on OS X. And then people tried to start putting it in the cloud, and we found out the only cloud it ran in without problem was GCP because it was the only one that allowed nested virtualization. You could move it to a bare metal VM instance in AWS and Azure, but they got expensive very quickly. There are other ones like the ARM instances, I think, that are cheaper, but it kind of became a non-happy path. That said, Firecracker is still on the short list for like a Nexlet that Synadia might make first class. That list is still being defined. However, a community Firecracker Nexlet would be awesome.
And I saw somebody, I don't know if you touched on this much, but somebody was asking about a Dino Nexlet, and I was wondering if you touched on
Uh,
the isolate.
so so the way originally we used a V8 implementation called V8 Go in the first version of Next. It didn't feel like that was being maintained. So again, we started looking out and we landed on Dino isolates. In our cloud offering, if you are to submit a JavaScript function, so as a function as a service type thing, which I did not demonstrate today, that is running as a Dino isolate. So we take your function, we wrap it to be to protect ourselves. We expose some global functions. So like interacting with KV, interacting with PubSub, all that's going to be free. You won't have to code that. You'll just have to call the global functions that'll all be documented for use.
And then Felix in chat asking if if Nexlet is possible on Windows.
Yeah, so that's why we broke it apart. So if our client, so if the NATS client of your language will run on Windows, a Nexlet will run on Windows. We build completely on top of that. So much so, once you have your Nexus deployed, if you do a NATS micro LS, you can actually view all the free stuff we give you there. We give you like error codes, we give you like metrics, all that stuff you'll be able to leverage to kind of see the health of your Nexus.
This was definitely got a lot of chatter. People are very excited about workloads on NATS. And again, I think your demo is just so cool. So
Awesome. Well,
great work
I
on that.
have I have bad news for everyone. If that was exciting, wait till the next talk because we dog fooded Nex and it's really exciting.